one of our earlier videos in this section, and we kind of zoom in on this question here. I want to factor this rather challenging polynomial, 3x to the fourth minus 19x cubed minus 27x squared plus 359 minus 116. And we have a lot of information when we're factoring, but I sometimes say that, this is like cracking a coconut. You never know when it's going to break open. But I have this step here. I have this answer. The next step, it doesn't look obvious at all. In fact, this line right here took quite a few logical steps to reach here. So many that I put it on its own entire page. So there's an entire page to explaining how I got from this line to this line. I called it page A. All right, so I have a few things I like to use on something like this. Now the book is full of all sorts of tidbits and ideas, and they're good, but you might take a very different path to this. Plus, there are a few things that I put on here on this presentation that are certainly not in any book anywhere, and I try to explain that when I do this. So the first thing I like to do is what I call mock factor. And mock factoring is the idea that if I settle for the idea that if I multiply whatever the answer is, this does have an answer, something, something, something goes here. If I multiply it all out, I should get this. So logically, if I multiplied all the first ones, I should get 3x to the fourth. So my mock factor would be, there should be a 3x, an x, an x, and an x. Now, this actually is right. The only way to get 3x to the fourth, a polynomial like this, would be to have x's in those spots. So that wasn't all that brilliant or surprising of a move. But the mock factoring comes in here with a 116. Now, by the way, I'm completely ignoring what's in the middle for now. But what about 116? What are the factors of 116? Well, I'll write them off here off the side. They're 1, 2, 4, 29, 58, of course, 116. So what I really want you to do, literally want you to do, is guess. I don't care if you're wrong, just guess. What are you going to put? If you know you had to put numbers that make 116 here, and the reason why I call it mock factoring is we're not even trying to get it right. We're just trying to get a feel for this problem. Well, I think what I did when I tried this was a 1, 1, 4, and 29. We know that 4 times 29 makes 116. So if I were to multiply all this together, this times this times this times this, I'm not even putting the signs to worry about whether it's negative 116. This is one possibility. It's extremely unlikely that you would get the right answer from mock factoring. In this case, it's not right. But I think that gives you a feeling for what's possible and what's not possible. And here's what here's the way this is going to play out. I know, for example, there's no way there could be a 3 here. X minus 3 or x plus 3 couldn't happen, because 3 is not a possibility, because where it's coming from, the source essentially of all of these little blanks right here is 116. And 116 doesn't have a factor of 3. So by setting up this factoring, it helps me realize what's not going to work. So we do have this thing called the rational zeros theorem. And the author explains it well, but basically the rational zeros theorem kind of plays off of what I just talked about with a mock factoring. And that is the possible zeros that we could get. Now, the 0 for this parenthesis is actually 1/3. Do you see that? If I set this equal to 0, I'd get 1 divided by 3. I'm assuming there was a minus there, so I'll say plus or minus 1/3, depending on what sign I put in there. So the 0 here would be 1 or minus 1, depending on what sign, or plus or minus 4, plus or minus 29. So mock factoring kind of gives us these, but the rational zeros theorem gives us the list. I mean, it hands us the list. And basically, it's factors of 116 over factors of 3. Now, technically speaking, there should be a plus or minus on every single one of these. But I'll do that and leave it for now. But what I really want to talk about is this next idea that I call sloppy graphing. And by the way, I put my initials next to mock factoring and sloppy graphing because, you know, I say it and I don't think anybody else does. So what is sloppy graphing? Well, it's the idea that we have a pretty good idea about what this graph does, at least based on the lead coefficient and the lead monomial. We know what happens to x to the fourth, or we should. We should know that x to the fourth graphs behave in a certain way. They leave the box in quadrant 2. They might come down here somehow and go back up and leave the box in quadrant 1. So we know what we call the outside behavior on a graph like this. It's going to leave the box, leave the box. Now, the way I am drawing this, I'm just I'm not trying to be accurate at all. I'm just saying, you know what? At some point, the graph's got to leave the box out here in quadrant 1. At some point, it has to leave the box in quadrant 2. I wrote that a little less formally here. I said, you know, if x is negative infinity, and negative infinity isn't really, can't really put negative infinity in a graph. That's why I say it's informal. But if x is a negative number, y is going to be a very big positive number. If x is a very big positive number, y is going to be also a positive number. So I put that in there. Putting x equals 0 was pretty easy. It's just an easy calculation. If you put 0 in for x, I get negative 116. All right, and I'm looking for something. Geometrically, I am looking for something that, a point that's below the x-axis and a point, or I guess an arrow, that's above the x-axis. So what does this tell me? It tells me that there's no way to draw this graph, this sloppy graph, without crossing the x-axis somewhere where it's positive. And same thing over here. I'd have to cross the x-axis somewhere where it's negative. So in other words, I know there's going to be a 0 somewhere in here or somewhere in here, an intercept when I'm talking about graphs. All right, so that's just in the back of my mind. And then I say, start synthetic division. So the first thing I tried with my synthetic division is 1. So I put in a 1 and did the process, and I got 200. And that's off the camera, isn't it? Sorry. Okay. So this is the process of doing synthetic division with 1. I guess you could just say that was my first guess. I put in a 1, and I got a remainder of 200, which means f of 1 equals 200. Now the significance of that is this is going to be added to my sloppy graph. If x is 1, y is 200. And this is one of those moments where, you know, if this was a chess game, I'd announce mate in 3 or something like that. There is no way I can connect this point to this point without crossing the x-axis, and that means this is a 0. Now, I don't know where that's pointing exactly, because it is a sloppy graph, but somewhere between negative I'm somewhere between rather x equals 0 and x equals 1. There has to be a number that gives me a 0, and that's what I'm looking for. Well, when I look at my list of zeros, there are only 2 of them that are between 0 and 1. 1/3 and 2/3. And like I said earlier, when we mock graphed this thing, we thought 3x and 1 was a possibility, at least I did. So, yeah, I tried 1/3. And it paid off. 1/3, when I go through the synthetic division, gave me a 0. So I wrote bingo here, and that's a little hard to read. It says f of 1/3 must equal 0. So the significance of that means I can actually write down this second line on this problem directly from the synthetic division. Let's see, it looks like I got a typo here. Okay. Oh, I flipped those. All right, so x minus 1/3. This is the 3, the 18, the 33, and if that's correct, this should be 348. All right. If you jotted it down before, there it is, correct. All right. So that'd be 348. All right. So this is the idea that after you do synthetic division or long division, you can write this plus the remainder. But remember, the remainder was 0, so I factored this. Hallelujah. It took, writing the size I'm writing and explaining it all, it took me a whole page. But it took me a page of some interesting work to do this one line. All right, now this next step is not a big step. If you notice that all of these can be divided by 3, I can factor out a 3. And so it gives me this. Welcome to a new page, as the song says. All right, so how am I going to continue this problem? I'll go ahead and reveal the answer. The next step is that this gets recopied and this can be factored. What side work or what am I doing to get that? Well, that's all on this next page, page B. All right, so same idea. I start off with a mock factor. If I have 1/16, maybe I'll think of, 1, 4, and 29. And again, I'm not saying those are right. I'm just saying try anything. And it gives you a feel for the problem. More formally, the rational zeros theorem is every factor of 1/16, and since this is a 1, I don't have to worry about it. The coefficient of x cubed is 1. 1/16 over 1 would be literally how it would be written. But anyhow, these are all those rational zeros. And let's start my sloppy graph. So my sloppy graph is a little different on this one because what? We're talking x cubed as the lead coefficient. So x cubed does this. It leaves the box in quadrant 3, and it leaves the box in quadrant 1. And this time, the f of 0 is 1/16. So I had to try something, and I tried, well, by the way, where am I looking? I should be looking at the negative numbers because it's possible that I connect these without creating an x-intercept. I want to look where the intercepts exist. By the way, this is called the intermediate value theorem, and it's pretty important. It's the idea of if you have a sign change on the y-axis it means you have a 0 between those points on the x-axis. All right, so here's the first thing I tried, -2. I just picked something out of my list. Sorry. Here, actually, I should have gone with my gut instinct. It turns out 2 doesn't work, but 4 does, and we'll see. But anyhow, I tried 2, -2, and I get 106. Let me kind of plot that. If I have -2, here was 116. At -2, it's 106. So right here, it's 106. Well, what does that mean? It means there's still room for that sign change. I know that. In other words, it's positive here, it's positive here. It's probably not going to be between these two, any zeros there. So let's just keep on going further out. Well, further out means -4. So if I try -4, I will get a 0, which is what this is all about. I put in -4, I do the synthetic division, I get 0, I get to yell bingo, and what that means is x plus 4 must be a factor, because x minus -4. All right, so that must be a factor, and this must be a factor. So I'm putting all of that together, and I'm saying that that is how I did this next step. Sorry about all the papers moving. All right. That's how I did this next step from the cube to here. So here I am. By the way, I can go back to the original mock factoring. You can see how far off I was. I guess I did have 3x minus 1, and I'm not sure if I certainly didn't have signs in it, but I might have had x plus 4, and I might have had 29. But it turns out this doesn't really factor the way I might have guessed. In fact, it doesn't factor. Not traditionally, not over the integers. So what I have to do is come up with another page. Page C is the page that's going to finish this off for me. I probably had enough space to write it on this page, but I just wanted you to be able to look at this whole problem and understand the work that goes into each step of the process. So I'm here, and I want to figure out what goes here. And it's really just one thing that you're all familiar with, the quadratic formula. So if you're trying to factor this, the way we factor it is to find the zeros. So we're using the quadratic formula to find the zeros, and I get that they are 5 plus 2i and 5 minus 2i. So what do we do once we find a 0? Well, it's x minus c. That's the factor. So x minus this first one turns out to be this parenthesis. X minus the second one turns out to be this parenthesis. And that just gets added to the chain, which is this problem. So that's my take on factoring. I'll try to get a good aerial view of this whole problem. This angle's really hard to do. Got my gear in the way. All right. But that is factoring in section 4.6, I think this comes from. Anyhow, this is something that you have on the homework. And as a matter of fact, I got this from the website. So some of you might get this very problem. I think some of you will get something a little different. What I noticed was every time this thing regenerated, it always had that -4 or x minus a negative x plus 4 part right here. So keep that in mind if you ever encounter when you encounter this problem. But that is factoring, or what I sometimes call factoring on steroids. See you in the next video.